Good day everyone. In this video, we will discuss the remainder theorem. The remainder theorem says that if a polynomial p of x is divided by x minus c, then the remainder is r equals to p of c. Meaning, for us to get the value of the remainder, we just have to get the value of x, which is equal to c, and then solve for p of c. We'll get to understand this better if we discuss the examples. In the previous discussions, I taught you how to divide using long division and synthetic division. And using this process, you were able to identify the remainder of the polynomials being divided with a binomial. This time, we will be using remainder theorem for us to get the remainder easily. So we will be using the idea that the remainder is equal to p of c. So if we're going to apply remainder theorem with these examples, we'll have p of 2 is equal to 2x raised to 4 minus 3x squared plus 4x plus 5. Simply substitute the value of x, which is equal to 2, or the divisor. So our answer here will be equal to 33. See, it's easier than doing long division and synthetic division. But take note, you can only use this one if your task is to get the remainder. Here are the examples that we will be solving in this video. Let's find the remainder when each polynomial is divided by the corresponding binomial. In these examples, we will just compute for the remainder. So we will use remainder theorem to get the answers. For example number 1, we have 2x raised to 4 minus 5x cubed minus 6x plus 2 divided by x minus 5. You will notice that in our dividend, there is a missing term. Just like doing long division and synthetic division, we always make sure that our terms are complete and it must be arranged in decreasing power of x. But in this case, in this lesson, remainder theorem, there is no need to add the missing terms because it will be useless to add 0 and then the missing coefficient, where in fact we will just substitute the value of x. Okay, so let's just proceed to getting the value of x here. The value of x here is equal to c, and c is equal to that number that we will be substituting later. So to get the value of x, we just have to equate that to 0 and find the value of x that's equal to 5. So here is our solution. Take note of remainder theorem that whatever is the result of your p of c, that's your remainder. So let us rewrite that. We have p of 5 is equal to 2x raised to 4 minus 5x cubed minus 6x plus 2. Take note that x is equal to c and c is equal to 5. That means x is also equal to 5. So let us just substitute the value of x here, which is 5. We have 2 times 5 raised to 4 minus 5 times 5 raised to 3 minus 6 times 5 plus 2. And then we simplify this one. Let's work on those numbers inside the parentheses. Always remember that we have to follow PEMDAS. So let's simplify 5 raised to 4, that's equal to 625. Copy minus 5, and then 5 raised to 3 is equal to 125. Negative 6 times 5 is equal to negative 30, then copy plus 2. Simplify further, we have 2 times 625, that's equal to 1250. Negative 5 times 125 is equal to negative 625. Let us subtract these two numbers. We'll have the answer of 625. And then we subtract 30 here. We'll have the answer of 595. And then add the last number, that's 2. That's equal to 597. That means p of 5 is equal to 597. And 597 here is our remainder. Now we are on our second example. We have x raised to 4 minus 10x cubed plus 2x squared minus 8x plus 15 divided by x minus 1. So the same process, let's find the value of x, equate that to 0, and then x is equal to positive 1. And then substitute positive 1 to our polynomial function. We have 1 raised to 4 minus 10 times 1 raised to 3 plus 2 times 1 raised to 2 minus 8 times 1 plus 15. And then we simplify this one by following the PEMDAS rule. Let us simplify those numbers with exponents. 1 raised to 4 is equal to 1. And then 1 raised to 3 is equal to 1 times negative 10 is equal to negative 10. 1 raised to 2 is equal to 1 times 2 is equal to positive 2. And then negative 8 times 1 is equal to negative 8. And then just copy positive 15. And then we simplify this one further by adding and subtracting. Let's work on the left side going to the right side of this equation. So we have 1 minus 10 is equal to negative 9. Negative 9 plus 2 is equal to negative 7. Negative 7 plus negative 8 is equal to negative 15. And then negative 15 plus 15 is equal to 0. That means P of 1 here is equal to 0. And then the remainder is also 0. Let us discuss the last example. We have 3x raised to 4 plus x cubed minus 2x squared plus x plus 12 divided by 2x plus 1. Let us compute for the value of x, and that is to equate 2x plus 1 to 0. Transpose positive 1 to the right side of the equation. We have 2x is equal to negative 1, and then divide both sides by 2 to obtain the value of x. That means the value of x is equal to negative 1/2. So we will be substituting negative 1/2 to our polynomial function. So we have 3 times negative 1/2 raised to 4 plus negative 1/2 raised to 3 minus 2 times negative 1/2 raised to 2 plus negative 1/2 plus 12. And then we simplify those numbers with exponents. So let us simplify this one. We have negative 1 raised to 4, that is multiplying 1 4 times, that's equal to 1. Negative 2 raised to 4, that is equal to positive 16. Let's move on to negative 1/2 raised to 3. Take note that you have to distribute our exponent to the numerator and denominator. So we have here negative 1 raised to 3 is equal to negative 1, and then negative 2 raised to 3 is equal to negative 8. Then just copy negative 2 and then simplify negative 1/2 raised to 2, and that is negative 1 raised to 2 is equal to positive 1, and then negative 2 raised to 2 is equal to positive 4. And then just copy negative 1/2 and then positive 12. Let us simplify this one by multiplying 3 times 1 over 16, that's equal to 3 over 16. And then just copy minus 1 over 8, multiply negative 2 to 1/4, that's equal to negative 2 over 4, and then copy minus 1/2, then copy plus 12. You will notice that we have a dissimilar fractions here, different denominators. So what you're going to do is you have to get the LCD or the least common denominator. So in this case our LCD is equal to 16. And then let's proceed to simplifying our fraction by using two operations, and that is division and then multiplication. We have 16 divided by 16 is equal to 1. 1 times 3 is equal to 3. Next fraction, we have 16 divided by negative 8, that's equal to 2, times 1 is equal to negative 2. Next fraction, we have 16 divided by negative 4, that's equal to negative 4, times 2 is equal to negative 8. Then we have 16 divided by negative 2 is equal to negative 8, times 1 is equal to negative 8. And then 16 Remember that if it's a whole number, it's understood to have 1 in the denominator. 16 divided by 1 is 16. Then 16 times 12 is equal to positive 192. And then we simplify this one by subtracting and adding the numerators. So we have 177 over 16. We leave our answer in this form, improper fraction. That means our remainder here is equal to 177 over 16. Let us gather all the answers of our examples. For the first example, we have the remainder of 597. For number 2, we have the remainder of 0. And for number 3, we have the remainder of 177 over 16. That's all for today. Thank you for watching. I hope you learned something. If you haven't subscribed yet, please don't forget to subscribe and hit the bell button to update you on my next videos.